Hello everyone. Today I am going to explain the solutions of problem A to D of yesterday's Codeforces round 773 div 2. So let's start with problem A. In problem A, Sam lives in Awesomeburgs. Its downtown has a triangular shape. Also the following is true about the triangle. Its vertices have integer coordinates. The coordinates of vertices are non-negative and its vertices are not on a single line. He calls a point on the downtown's border safe if he can reach this point from at least one point of the line y equal to O, walking along some straight line without crossing the interior of the triangle. Find the total length of the unsafe parts of the downtown border, and it can be proven that these parts are segment and their number is finite. So in simple words, the problem asks us to find the length of the boundary of the triangle where we cannot reach from the x-axis using a straight line without intersecting the boundary of the triangle. So let's say this is the a triangle we have. Okay, we will be given three coordinates x1, y1, x2, y2 and x3, y3. Now this is our x-axis. Alright, so what we have to do, we can use this x-axis, and from here we have to reach each and every point of the boundary of the triangle with a straight line like this. Let's say this is a straight line, this is a straight line, thus we have to reach each point of this boundary of the triangle using a straight line. And let's say we have reached this point like this, but we can never reach this point using a straight line like this, because in this case we are intersecting the boundary of the triangle, so this path is invalid. So now we have to tell that what is the length of the boundary of the triangle which we can never reach. Now if we observe closely, we will be able to find that we can always reach any point of the boundary of the triangle, so except one case. So what is that case? So let's say this is our x-axis, okay, and this is our y-axis, and let's say our triangle looks like this, where exactly the upper side of the triangle is parallel to x-axis. Okay, x1 y1, x2 y2 and x3 y3. In this case what happens, this line is parallel to x-axis. So in order to reach this line, we will have to go there by intersecting the other side of the triangle this way, but we can never intersect the other boundaries of the triangle to reach another boundary, so this is not a valid path, neither this is. So let's say another triangle is like this. In this case we can reach every point of the triangle like this. So finally what we have to find actually is that whether our triangle looks like this. And how can we find that? We can just check whether between our 3 points, okay, whether between our 3 points 2 of them have same length of y or not. If they have same length of y, then that means they are parallel to x-axis, that line forming by those 2 points. Also we have to check in that case whether this is that parallel line is the upper side of the triangle or not, because if it is not upper side like this one, then it is not a problem. I mean, in that case we can reach each and every point of the boundary. So how can we check whether that this line is the upper line or not? To do so, we can check whether the value of y, whether the value of y is greater than the other point, like x3, in this case x3 y3 is y3. Which I am trying to say is that whether y1 is greater than y3 or not. If y1 is greater than y3, that means this line is the upper line. so then we will never be able to reach this line. So the answer will be the length of this line, which is x1 minus x2, because we can never reach this side, so the length of this side is the answer. So let's see the code. Let me zoom it. So yeah, first initially I take the input x1 y1 x2 y2 and x3 y3, and now I just check whether there are three cases, right? Either I mean three combinations where 2 points will be parallel to where the line formed by 2 points will be parallel to x-axis. So I check whether y2 and y3 is equals or not. That means x2 y2 and x3 y3 will form a parallel line. In that case, the other point y1, that other point x1 y1, that point's y coordinate should be lesser than y2 in order to x2 y2 and x3 y3 to be the upper parallel side. So if that's the case, then I print the length of the x2 minus x3. Same way I check for y1 y2, and also the same way I check for y1 y3, and none of these are if none of these are true, that means we will always be able to reach each and every point of the boundary of the triangle. So I print 0, because there will be not a single length which is unreachable. So yeah, that was problem A. Now let's see problem B. In problem B, Sam is a kindergartner and there are n children in his group. He decided to create a team with some of his children to play Brawl Go 2. Sam has n power-ups, the ith has type AI, the child's strength is equal to the number of different types among power-ups he has. For a team of size k, Sam will distribute all n power-ups to k children in such a way that each of the k children receives at least one power-up, and each power-up is given to someone. For each integer k from 1 to n, find the minimum sum of strengths of a team of k children Sam can get. So the problem says that we will be given n different types of push-ups, like here 1 1 2, and we will form 1 to n sized teams every time. Like for first we will create a 1 size team, then 2, then 3, and up to n size team, and every time we have to, let's say currently we have a k sized team, like there are k players and we have n greater than k, n push-ups. Okay, now we have to distribute these n push-ups among these children such that each children at least gets one push-ups. Okay, so there, let's say first I give one push-ups to each children, so now there will be left n minus k push-ups, and I have to distribute this remaining push-ups also among these children, which means I have to use all these push-ups for a k sized team. Also each children have to have at least one push-ups, and for each k sized team we have to print the minimum sum of strengths of children in a team of size k. Now what is the strength of a children? Let's say there are two teams. Okay, let's say there are two, currently this is a two sized team. So if this player has x y x and this player has a x, okay, so this player has two different types of push-ups, so here the sum is, here the strength is 2, and also this player has two different types of push-ups, so here also the strength is 2, so the total strength of sum will be 4, and we have to minimize that, which means for each player we have to minimize different types of push-ups. So always we will try to give the same types of push-ups to a single team, I mean a single player, if that's possible. So let's see how we can do that. First, here is a test case which they have already explained, that if n is 3 and there are two types of push-ups and 3 push-ups in total 1 1 2, when k is 1, the size of team is already 1, so we have to give all the push-ups to the single player. In this case the answer will be 2, because in this case answer will be 2 because there are two different types of push-ups in a single team. When k is 2, we will have to distribute these push-ups in two teams. So what we have done, we have given 1 1 to one team and to another team, because we have tried to reduce the number of different push-ups for a single team. So in this case answer is 2. And when k is 3, we will always have to give one at least push-ups to each and every one. So here the answer is 3, because this team gets one different type of push-ups, the second team gets one different types of push-up, and the third team gets a different type of push-ups. Now let's see for example 5 1 2 2 2 4. So let's say n equal to 6, okay, and the array is 5 1 2 2 2 4. So there are actually 3 different types of push-ups, 4 different types of push-ups: 1 2 3 and 4. Now when k is 1, right, when k is 1, we have to give all these types of push-ups to a single player. So then what will our answer be is nothing but 4, because there are 4 types of push-ups and all these types of push-ups will go in one single team. Okay, now let's say k equal to 2. In this case we have to distribute these push-ups in 2 different teams. So what we can do, we can give one player one type of push-ups. Let's say we give one to one player, and we give the other 3 types of push-ups to another player. Because see, if we give one player 1 and 2 and another player, here it will be 2 2 2 4 5, we can do this. Also we can do this 1 2 2 2 4 5, but in this case the sum will be here 1 different type of push-ups, here 3 different type of push-ups, in total 4. But in this case for the first player there are 2 different types of push-ups, and for the second player there are 3 different types of push-ups, so the sum will be 5. So this one is greater, so we should never take it. So what is the what is the better way to distribute the push-ups? We should always give a particular type of push-up, all particular type of push-ups to a single player. Okay, so again for k equal to 3, we can simply give one push-ups to one player, the second push-up 2 to another player, and the rest of the different types of push-ups, which are 4 and 5, to the third player. Okay, now when k equal to 4, in that case again there are 4 different types of push-ups, right? So we can give each type of push-ups to each player. One get 1, another get 2 2 2, another get 4, and the last player gets 5. Now when k equals to 5, then the answer starts changing. When the number of players is greater than different types of push-ups, because see, there are 4 different types of push-ups. Now there are 5 different teams: 1 2 3 4 5. Now this is for sure that we can never distribute these 4 types of push-ups in 5 players and we can still get the answer 4, right? So this means that if we, let's see the answer for 4. So if our answer was 4, we would have our k was 4, then we would have distributed the push-ups like this. Now there is one more player left and we have to give him something. So see, there are 3 2s here in the second team. So what we can do, we can bring 1 2 from here to here. Thus the answer will be 1 2 3, here one different type, one different type, one different type, one different type, and another different type. So answer will be 5. So when the size increases, that the size of the team increases, then distinct different types of push-ups, then we just need to increase our answer also, because we can never distribute just 4 push-ups among 5 students. So we have to use a same type of push-up for 2 different students. Also for k equal to 6, the same way we will distribute like 1 2 2 2 4 5. So the answer will be 6, because here is one type, here another type, and the sum of all these types is 1 plus 1 plus 1 plus 1 plus 1 plus 1, which is 6. So that was the problem B's observation. So the code is like this. Yeah, so first initially take the input n and store all the inputs in an array, which is not necessary though. Now I maintain a map which will maintain the count of each distinct value. Then first, as I have shown that when the size of the team is less than equal to the distinct value present in my push-ups, the different types of push-ups presents in my push-ups, which is nothing but size of map, because map contains distinct keys. In that case, our answer will always be the size of map, which is 4. See, in these cases our answer will always be 4, and that is what I have printed here. And after that, as I have shown for this case, like for first 4 k size teams, because the size of distinct values is 4, the answer will always be 4. After that, we need to increase one player, so we need to take one of this push-up and keep it and give it to the newest player. So the same type of push-ups will be repeated again, so the answer will increase by 1. In the second case, the answer will increase by 2 from 4 plus 2. So that is what I have done for I size of map plus 1 up to n. So in this case, the size of k is greater than the distinct different types of push-ups, so my answer will be I. Okay, because right now I is 5, so my answer is also 5. Here I is 6, so my answer is also 6. And that is all we have to do in this problem B. Okay, now let's see problem C. In problem C, a sequence of positive integers is called grade for a positive integer x if we can split it into pairs in such a way that in each pair the first number is multiplied by x is equal to the second number. More formally, a sequence A of size n is grade for a positive integer x if n is even and there exists a permutation p of size n such that for each a p of 2i minus 1 into x equals to a p 2i. Sam has a sequence A and a positive integer x. Help him to make the sequence grade and find the minimum possible number of positive integers that should be added to the sequence A to make it grade for the number x. Now this is a very easy problem, this is even easier than B and A, for me at least. So let's see how we can do that. First, let's take this example. So we are given 5 numbers and we have to, our x is 3. So the numbers are 5 2 3, 5 2 3 15, 5 2 3 5 15. So basically the problem asks to make pairs from these numbers, to make pairs of 2 numbers from this given sequence of integers, such that for each xy, let's say the pair is AB, 2 consecutive integer, not consecutive, just from 2 numbers, take 2 numbers from this sequence, and let's say the 2 numbers are A and B. So A into B, let's say this is the smaller, A is smaller equal to B, so A into X must be B. Okay, so A into X has to be equal to B. And let's say we have currently there is another integer, let's say C, which is present in our sequence, so we need another integer D such that C into X equal to D. So currently D is not present in our sequence of, in our array. So in that case, what we can simply do, we can add this integer D into our sequence. Okay, and in that case we have to increase our answer by 1. Why so? Because this D was not already present in our sequence, so we have to edit it externally. And after, at the end, when we will make pairs for all these elements, after adding something, when we will make pairs, let's say for all of this element, then we will return that at least how many elements we have to add into the sequence, so that each element present in the sequence form this combination like A B, such that if one element is A, the smaller element is A, then A into X is equal to B. So we can very easily do it using multimap. What we can simply do is, for 5, 2, 3, 5, 15, see, we will first store all these elements in our multimap. So in our multimap it will be like 2, 3, 5, 2, 3, 5, 5, 15. Okay, and currently our answer is 0. Answer means how many elements we have added. Now we will go one by one to all these elements in our multimap. So first I will come to 2. Now the number I need is 6, right? Because currently I have A equal to 2. Now B is X into A, which is 3 into 2, which is 6. Now I will check if 6 exists in my multimap or not. Since it does not exist, so we can say that to make a pair containing an element 2, we will need 6. So in this case I can increase my answer by 1, because I will add 6 in the multimap, let's say. Although I won't, but I can assume that I will add an element 6, and then this 2 and 6 will make a pair. So now I will remove these 2 elements. Now my next element comes in the multimap is 3. So again this time I will need 15. Now 15 already exists in the multimap, so I won't be needing to add 15 externally to the multimap. So I can just take these 2 elements and make a pair, and I can just remove them, right? Now the next element is 5. For 5 I need 15. Actually sorry, I said something wrong here. Sorry for that, because X is 3, so B will be 9. Okay, so for 3 I need 9, but 9 is also not available in the multimap, so I will add 9 in the map. So my answer will increase to 2, and then I can just remove 3 and 9. Now comes 5, and I have to find 15 in my map. Now I can find that 15 already exists in my multimap, so I can just simply make a pair with 5 and 15. So I won't be needing to insert an element, insert 15 in the multimap, because that already exists. So these two makes a pair, and they will be removed from the map. And lastly, the last element in the map is 5. So for 5 again I need 15, but 15 does not exist in the multimap, so I have to add 15 externally. So I will add 15, so that my answer will get increased by 1, and then 5 and 15 will make a pair, and they will also be removed from the multimap. So finally the answer should be 3, and yeah, their answer is 3. So this was a very easy problem. Let's see the implementation. So first we take the input of n and x. I create a multi-set where I input all those elements, and now until my set is empty, first I take the smallest value currently present in my set, and I check the in my needed, I stored the value I need to make the pair. Now I try to find whether that value exists in my map already or not. My set, that value exists in my set or not. So if that element does not exist, if that element exists in the map, in that case we can simply make the pair with those 2 elements, and we can erase them, and we don't have to insert any elements by ourselves. So we can just simply erase those 2 elements. And if my needed value does not exist in the map, in that case first I have to insert one integer, the needed value, in the map, then those 2 elements will make a pair, and then we have to remove those two elements from the map again. So I have simply erased the first value from the map, and I have increased my answer by 1 because I have inserted one element this time, and finally the answer will be printed. So that was problem C. Now let's see problem D. Like, this problem was really hard to implement. During contest time I got the approach, but I was unable to implement it because for me it was really hard to implement this problem. So yeah, let's see this problem, the last problem, D. So in problem D, Olia has an array of integers a1, a2, a2 up to an. She wants to split it into tandem repeats. Since it's rarely possible, before that she wants to perform the following operation several number of times. Insert a pair of equal numbers into an arbitrary position. And now, which the problem asks, it says that a tandem repeat is a sequence x of even length 2k such that for each I 1 to k the condition is xi equal to xi plus k is satisfied. An array A could be split into tandem repeats if you can split it into several parts, each being a subsegment of the array, such that each part is a tandem repeat. In one operation, you can choose an arbitrary letter C and insert CC to any position in the array, at the beginning, between any two integers, or at the end. You are to perform several operations and split the array into tandem repeats or determine that it is possible. Please note that you do not have to minimize the number of operations. Then we will be given an array, and in order to make that total array a tandem repeat, like there can be subsegments of the array which will be tandem, but in total to make the tandem repeats we have to print how many operations we need to do. Also we have to give the details of each operation, where each operation will consist two integer C and P. C will give us that what value we want to insert, and P will give us the index where we want to insert that element. Also after that we have to print the length of those tandem repeats in our array, the length of the subsegments of the array which are tandem repeats. So yeah, let's understand this problem more clearly. So let's say the array is like 1 2 1 2. Okay, so a tandem repeat is nothing but if my first part is ABC, then just after that there should be ABC again. This is a tandem part because this is the middle point, and after middle point each element, if I just break it into two equal parts, the each element, the ith element of each part will be equal. So this is tandem repeat. Now let's say we are given this array. Now this array is already a tandem repeat, right? Because this is 1 2 and this is again 1 2. So in this case we don't have to do any operation. Now let's say the problem, okay, let's say it was 3 2 1 1 2 3. Okay, now one thing to remember that at most we can do n square operations to make it tandem. Now the first observation that came into my mind, that if there are n square operations, that means in each iteration I can do at most n operations. Like I think that was 2 into n square, but let's take it almost around n square. So my main observation was that in each operations I can do at most around n operations. So see, 3 2 1. Now whenever I insert at index P some value x, I have to insert it twice. I have to insert it always twice. Now how can we make this a tandem? right? So see, initially my size of the array is 1 2 3 4 5 6. Currently my array is of size 6. Now in order to, let's say I want to make the tandem repeat started from here, okay, 3 and 3. So what I am actually wanting to do is I want to make a tandem part like this, so that here also exists 2 1 1 2. Now I can do that. How can I do that? First I see that the 3 and 3 are already present. Now I want to remove these two from my calculation, like I want to get done for the value 3. I mean I want to make the first tandem for here to here. So what I have to first do is I have to insert 2 at this index. Let's say I enter 2 consecutive 2's. I am leaving some space here because I will be inserting more. Now see, currently my 2 and 2's are equal. Now I need a 1. Okay, now what I will do, I will say okay, there are 2 2, and in between them I will again insert 2 consecutive 1's. Now this 1 and 1 is equal. Now I will come to this next element and I will say I need 1 again, so I will insert one more time 1. I mean 2 1's will be inserted, and the last element is 2, which I need, so I will insert 2's here. Okay, now if I check carefully, I will be able to see that this 3 2 1 1 2 is the same as 3 2 1 1 2, right? So this is a tandem repeat sequence. You can see that this length 3 2 1 1 2 3 2 1 1 2. So this way I have make this part tandem repeat. Now the left part is 2 1 1 2 and its length is 4. Okay, now if I want to make this part tandem, what I can do, see here is a 2. Now if a tandem part is like this, there are, I mean this is the first half, this is the second half, then this part also needs to start from x. So that is why when my first element is 2, I am trying to find that where does the other 2 exists. So here is the second 2, so I need to make tandem repeats, and the first half of the tandem repeats will be this one and the second half will be like this. So first I need 1, so I will insert 2 1's, then I will again need 1, so I will insert 2 more 1's. Now again this is a tandem repeat 2 1 1 2 1 1. So now the part which is left is 11 and its size is 2. So the 1 1 is already a tandem repeat, right? So we don't need to do anything, and these are the 3 tandem repeats of length 1 2 3 4 5 6, I mean 1 2 3 4 5 6 7 8 9 10, of size 10, of size 1 2 3 4 5 6 and of size 2. And how many operations have we done? Here we have done 1 2 3 4. We have inserted 4 elements, 4 operations. Here we have inserted 1 2 2 times, so 2 operations, and here we don't want I mean we have not inserted anything. So in total we have done 8 operations, which is lesser than n square, which is 36. So this way we can maintain we can create the tandem repeats. Now we have to check why does it work, right? So the first, let's see when it is impossible to make a tandem repeat. Let's say we are given a array like x y z z y and this. Now see here z occurs even times, like twice, y also occurs even times. Now let's say we want to make a tandem repeat from this one, right? Now whenever we insert an element 2 times. Now in a tandem sequence, if here is one x, then there must be another x. thus 2x will be consumed at a time, and here is 1a. I will insert 2a's here, right? Now for tandem sequence, this part will be used to making a tandem repeat, but this a will be left, so there must be another a to create a tandem repeat with this one, right? So what I'm trying to say that each distinct element should at least should occur even number of times in our given array, otherwise it is impossible to make a tandem sequence, because if there are odd number of x, see here is a x, so if I even put 2x here and let's say somehow I create a tandem sequence here, the next x will always be left, and to make a tandem sequence from this x we will again put 2x and we will use 1x, so it will eventually be impossible to make a total tandem sequence. So each distinct value should occur even number of times. That's the first case. Now in the previous example we showed that the initially size of the array was 6, then it turned to 4 and then 2. So for few examples I tried it and I saw that generally the size of the array decreases by 2 after doing this operation each time. Why so? Because let's say the array is like x and there are few elements, let's say y, z, and yeah, x, z, y. Okay, now my first element is x, so I try to make a tandem sequence of x, right? So yeah, like do like this, z, y and x. Okay, so there are in total 1 2 3 4 5 6 elements, n equal to 6. Now my first element and last elements are equal, so how many elements are left here? Here are 4 elements left, so I have to insert this many elements here. Like first I will insert 2 y's, then I will insert 2 z's, then I will insert again 2 z's, and then I will again insert 2 y's. So I am inserting 4 elements, I mean 8 elements, but I am doing this operation 4 times for a size array of 6, I mean for a size array size of 6, because in all those elements, in the worst case the equal to elements can be at first, at last, then I have to do the push, I mean inserting operation for all these elements. So if our size of the array is n, we have to do the operation n minus 2 times, right? And each time our array size will decrease by 2, because see here x, y, z, z, y, x, y, z, z, y, this part will be a tandem repeat. So now the size of the left part will be 4. You see, initially the size was 6 and now the size is 4. It decreases by 2 always, because we just get rid of 2 elements each time. So here we will do, for n size we will do at most n minus 2 operation. Here also we will do n minus 4 operations. So it turns out that for size it is always lesser than n square, right? Because if we do n operations for a n sized array every time, then only it can be n square, but also here every time our array size decreases by 2 and we do 2 lesser operations at most, so the total number of operation is always less than n square. So this proves that our this approach works. Now how can we do that? So simply what we will try to do, that if our array is like this 1 2 3 and 2 3 1, okay, first we will find first we will take our initial element, I mean the first element of our array, and I will try I will find where does this element comes again. So this is my starting index and this is my ending index, and I have to just make a tandem sequence for this part, right? Because I want to get rid of this one. So what I can do is I can insert, I need 2, so I can insert 2 2s here. So instead of inserting here, I will maintain another array. Let's say its name is insert. So what I am trying to say is that I will insert 2 2s here now, so like 2 2s. So I will maintain that what are the elements I am inserting. So initially the element is 2, then my next element is 3, so I will insert 3s here. So what I have inserted, I have inserted 3. Now I will insert 2 again, so I have inserted 2, then I will insert 3 again, and I have inserted 3. So this is maintained that what are the elements I have inserted. Now see, after this part is tandem, right? 1 2 3 2 3 1 2 3 2 3, this part, right? So the part we are left with, this is the part we are left with where we have to do our operations next time. So we can just delete these many elements from our array, and also we can say that for the next time when we will do some operations here, we have to also maintain the indexes, the indices where we are pushing the elements. But we can do that by just keep maintaining that what is the length of this much, 1 2 3 4 5 6 7 8 9 10. So I can just say like we are done for the first 10 elements. So whenever we will, let's say we just erase this part, okay? So now my array becomes 3 2 3 2. Now this index is 0. Initially it looks like 0, but we already have some done part initially which is of length 10. So my index will be 0 plus done, which is 10, right? Now how we will get this array? This is very simple. So it turns out that whenever we are inserting these elements, alright, these elements are inserted twice and one of them are used for making the tandem sequence and the other one is left. So that's why I have maintained the insert array. Now if I reverse it, it will be 3 2 3 2, and I just have to push it in this array. Thus we will get 3 2 3 2, and this is already a tandem sequence, so we won't have to do any operations. Also, when we are removing this part, first we will calculate that what is the size of this part, which is 10. So in our array, like we have to maintain also another array where we will store the sizes of each subsequence of the tandem repeat, and there I will insert 10. So that's all. Now I will show you the implementation, like how I did it. So first I take the input in the array, then I maintain the count of each element, and I check whether any of these element occurs odd number of times or not. If any element occurs odd number of times, I print -1 because it is impossible to make a tandem repeat from those array, that array. Okay, now I have two arrays, one of pair, vector of pair, and another is vector of integer. This pair will maintain that how many operations I am doing, and in each operations at which index I am inserting which element, and this length is for storing the length of the subsequence which are tandem repeats. And initially I am done with 0 elements, like as I showed that initially when my array was the whole array, then I was not done with any parts, so this is actually my index 0, so I currently my done part is 0. Okay, now now I just start. I will do these operations until my array is empty, because I showed you that every time my size will increase, my array size will decrease by 2. Also it is possible that my initially array size was 6 8, then I just do one operation, one time this thing, and the size becomes 6, and this 6 size array is already a tandem, so I won't have to do any more operations. But in the worst case it will be like 8 to 6 6 to 4 4 to 2 2 to 0. Okay, so always, as I showed, I am trying to make a tandem sequence for the first element of my current array. So my current element is a0. Then I mean the starting index is 0, right? Because I always try to make the tandem sequence from the first element, and currently I am trying to find that where this element comes again in my array. So it will always exist. So my ending index will be that, like if my this was starting index, this will be ending index. So I have to do operations for these many elements. Okay, now I have maintained a vector insert as I showed here, like this one. The elements need to insert to get a tandem for a0 to ae minus ei minus end index minus 1. Then I simply go for each these elements, and as I showed that I have to insert 2 times here. So what is the element I have inserted? It is 2. So I am just inserting those. Also, see, in our actual array also we will insert 2, right? We will insert 2 times. So this 2 comes where? I mean, at which index do we put it? We put it I minus si plus ei plus done. Now how is it so? See, let's say we are inserting for this element. So this is 2 elements away from our starting index, right? So this is 2 elements away from our starting index. This is I minus si, and we have to put this element at 2 index away from our ending index also, because if this comes after just after one element of starting index, then this should come just after one elements of ending index too, because their order has to be same now. Because if this is abc, then if b comes just after a, here also b will come just after a. So I do end index plus I minus start index, also plus done, because plus done will eventually tell us that how many elements we are previously done with, because that is actually that many elements exist in our arrays first part, but we have removed that for our for better calculation. So I have added done. Initially it is 0, and I am inserting the aith element, because I am inserting this element, right? So it will be like 2 3 2 3. After that I have, that's why, see, now my array was like this, right? 1 2 3 2 3 1 2 3 2 3. This part was tandem sequence, so I have to remove it. Now that's why I have just reversed it, and I have removed all these elements, and then I have reversed it again to get this array. So that is what I am doing here. I have just found in the delete that how many elements I need to remove, and I have removed those, and then I have reversed it again here in this line. But before reversing, see, currently I mean these are the elements I need to insert here, right? But this is the actual order, but currently my array was reversed. So I have just reversed this one too and inserted it. Like I have inserted it like 3 2 3 2. Currently my v was, I mean in my array A I have inserted like this, and I have reversed it to 2 3 2 3. And then I have tried to find that what is the length of this tandem sequence. I have just worked to it, like this was the starting index, this was the ending index, right? So the length was ending index minus starting index, this into 2, because this comes here again. So this is a tandem repeat part. So I push that in my lengths array, which is actually storing the lengths. And see, now I have removed these many elements, so we are done with this much elements. So when our next index is 0, I mean new array, this is actually, we need to add an offset, because these elements should have existed in our array before this element. So I have increased my done by 2 into end index minus size, which starting index, which is the size of the offset. So after this is done, I just printed the size of the pushes. For each push I just print the point index where I'm pushing the element and which element I'm pushing. Then I also print the sizes of each tandem repeats, and that was it. So this was the implementation of problem D, which was really hard for me to implement and it took quite some time. So yeah, that's it, and thanks for watching.